Sir, mic mute ആണ്.
Thank you. We have seen the basic properties of multi-rate signal processing. We have derived the properties of basic multiprocessing. Today we will see how they are used for implementing, say, complex filters using polyphase decomposition. So last class we just saw the beginning of what is polyphase decomposition. Today we will see it more elaborately and clearly. So coming to the presentation. Okay. So I hope the screen is clear to you and I'm audible clearly. Am I?
Yes.
Okay. So probably take full screen. Just a minute. Okay. Okay. So we shall see what is basically polyphase decomposition. So let us take an example of, say, h equal to 1 plus 3z inverse plus 2z raised to minus 2 plus 6z raised to minus 3 plus 4z raised to minus 4 plus say 5z raised to minus 6. So minus 5 plus say 7z raised to minus 6. So how will you normally implement this? This is an what kind of filter?
So presentation
Presentation is not clear to you?
sir, actually the board is not visible. Actually it shows presentation only on the screen.
Is it like that to all of you?
Yes, sir.
Yes, sir, the presentation is not visible.
Okay, let me see. Okay, is it visible now?
Yes, sir.
Yes,
Yes.
sir.
So this kind of filter, is it an FIR filter or IR filter?
FIR.
This is an FIR filter. So how do we implement this? This is basically implementation is you take a delay set inverse, you multiply it with 3, add it here. Again, you take a delayed version, multiply it by 2, right? Then again you take a delay, multiply it by 6. So like that, you have up to 7, last tapping of 7. Okay, so these are all added together. This is how we normally implement this kind of FIR filters. But we know that HZ can also be written as, say, 1 plus 3z inverse plus 2z raised to minus 2 plus z raised to minus 3 plus 4z raised to minus 4 plus 5z raised to minus 5 plus 7z raised to minus 6. This can be written as, so let us write the first 3 terms here. 1 plus 3z inverse plus 2z raised to minus 2. Remaining terms, okay. Let us write it as z inverse into let us assume that there is one more term, say z raised to minus 7, z raised to minus 7. Okay, so let us take first 4 terms together. Okay, 2z inverse plus 6z raised to minus 3. Then what else do we have? We have 4z raised to minus 4 plus 5z raised to minus 5 plus remaining terms. So let us take z raised to minus 4 outside from that. Okay, or rather than doing this, we can also split this as 1 plus 2z raised to minus 2 plus. Let's take these terms. This term, okay, and this term together. So you have, what do you have here? You have 1 plus 2z raised to minus 2 plus 4z raised to minus 4. Then remaining terms, what are the remaining terms? You have 3z raised to minus 1 plus 6z raised to minus 3 plus 5z raised to minus 5 plus, okay, let us take 7, this also along with this first combination, 7z raised to minus 6 also with this. So we have 7 z raised to minus 6 also here. So remaining terms are 3z inverse plus 6z raised to minus 3 plus 5 z raised to minus 5 plus last time z raised to minus 7. Now this you can write as this you can basically write as 1 plus 2z inverse plus 4z raised to minus 4 plus 7 z raised to minus 6 plus, let's take z inverse outside from these terms. So remaining you have 3 plus 6z raised to minus 2 plus 5z raised to minus 4 plus z raised to minus 6. Okay. Or 2z raised to minus 2 here plus 4z raised to. So you have 2 terms here. So let us consider the first term, or let us take E0z as 1 plus 2z raised to minus 1 plus 4z raised to minus 2 plus 7z raised to minus 3. Then can you tell how can you write the first this term in terms of E0z?
E0 z square.
It is E0 z square. Correct. And what about the second term? Let us call this E1 z. Let us call the second term, or the polynomial 3 plus 6 z inverse plus 5 z raised to minus 2 plus z raised to minus 3 is E1 z. So can you tell what is this this second term?
E1 Z square.
Correct. It is E1 z square. So basically, whatever you are having as hz is E0 z square plus z inverse into E1 z square. Okay. So this is the E0 z, E1 z, etc. are the polyphase decomposition. Polyphase decomposition need not be necessarily like this. You can take, say, if you have arrays or if you have sequences like this, what we have done now is we have taken alternate samples, right? We have taken alternate samples, and the other alternates you have put as E1 z. It's not necessary that we have to take it like this. You can take first one like this, then two sequence you can leave, you take third one, then again you leave 2 sequence, you take. So like that you can take one sequence. which you can call E0 set. And another set of even set you can take as this one, that is the second one. Okay, second term. Then you can take another one, which is the third one, which you can call as E2. Okay. Yeah. I think the background color changed just a minute. Okay. Yeah. Then the third one is this one. Here you have third one. Here also you have third one. Here also third one. That can be the E2 set. So you have E0 set, E1 set, E2 set. Here you have E0 set and E1 set, but you can have, in these cases, you can have E01, E1 set and E2 set. So depending on how many, what is the upsampling or what is the sequence interval you are taking, so depending on that, you will get the corresponding polyphase decomposition. Now let us try to implement this E0 set and E1 set, or the implementation we have used here, that is we have seen this implementation. This is the implementation we have seen for H set. Now let us see it for the case of say including E0 set. So H set is basically E0 set plus set inverse into E1 set square plus set inverse into E1 set square. So if you try to implement this, H set implementation will be, you will have a filter called E0 set square. We'll pass it directly through this, the XN signal. Then you will take a delay, set inverse. Then you will pass it through the E1 set square. E1 set square. Now you have to add this to get your Yn. And E0 set square is basically, you know what E0 set square is. This is E0 set square, 1 plus 2 set raised to minus 2 plus 4 set raised to minus 4. This is basically your E0 set square and E1 set square, which is also implementable using delays. Now, okay. So this is how polyphase decomposition is done. Now suppose you have some downsampler. Okay, let me ask something. Suppose you have E0 set square here, and you have a downsampler by factor of 2. Suppose you give input as Xn, and you get Yn. Okay. This, can you write this as E0 set? Is this possible? Are they the same? E0 set square downsample by factor of 2. Will it give a downsampler by factor of 2 pass it through a filter E0 set?
Yes.
Okay. So you know these identities now. When you have, say, an H set followed by an upsampler by factor of L. This is same as an upsampler followed by H z raised to H. All this we have derived and proved, right? Okay. So this is the basic polyphase decomposition. Polyphase decomposition. Okay. Yeah. Now, suppose you have, say, hello. Class le sir, M.Tech le class. M.Tech le class sir. Okay. ഞാൻ ഷെയർ ചെയ്തിട്ടില്ല അന്നത്തെ okay. Now P0 set square, we have this set square. Now let us try to see what happens when you have an H set followed by a downsampler. In this case, so H set, you know, it is E0 set. We have E0 set here, E0 set square basically, and you have a delay. Yeah. Then you have E1 set square. You add it together. This is basically your set. Now you have a sampler here. Downsampler here. Okay, so if you have H set and 2 like this, you can connect it to this one, and this downsampler can basically go to this side. This can be replaced or moved to these two places because you are adding this together. By distributive law, you can put these downsamplers here. So basically your signal becomes, or your setup becomes E0 set square followed by a downsampler, a factor of 2, and an adder. That is E1 set square. To have the downsampler here, like this. So this is the same setup. Now you can visualize that this can be again rewritten as Xn followed by a downsampler here. Then this, if you pass through the downsampler and reach here, it will be basically downsampler by factor of 2 followed by E0 set rather than E0 set square. Here. Then you have set inverse. Same thing happens here. You have a downsampler and you have E1 set. Then you add it here as by now you can see that we have a downsampler here. You can put this downsampler to the side. So So it can be xn, pass it to a downsampler by a factor of 2. Then you have a 0 set. Then you have a delay, pass it through, E1 set, add it, then you get AF. This can also be written as a downsampler followed by another filter, a simple filter, set inverse into E0 set by E0 set as well as E1 set and add a filter. So what you can see here is basically you had H set followed by downsampler by a factor of 2, and H set was polyphase decomposed to E0 set and E1 set, and this can be redrawn or reconfigured as a downsampler followed by a downsampler followed by the polyphase decomposed factors without set square. That is, they become E0 set and E1 set. So if we try to implement this, it will be downsampler. Then we have to write Excel here. We have E0 set as well. So what is E0 set? E0 set is basically 1 plus 2 set raised to minus 1 plus 4 set raised to minus 2 plus 7 set raised to minus 3. Okay. So plus 2 set raised to minus 1 plus 4 set raised to minus 2 plus 7 set raised to minus 3. And what is E1 set? E1 set is E1 set is 3 plus 6 set inverse plus 5 set raised to minus 2 plus 6 set raised to minus 3. Okay. 3 plus 6 set raised to minus 1 plus 5 set raised to minus 2 plus set raised to minus 3. So if you try to implement this is basically 1 plus 2 set inverse, which you can write as say 1, you pass it as such, you take a delay, multiply it with 2, again you take a delay, multiply it with 4, then you multiply it with 7, add them together. Then okay. So this is E0 set and E0 set. Then here you have a delay. Then you take E1 set. I'm taking a longer route here. E1 set is basically this you pass as such. You take a delayed version with here you have a multiplication factor of 3. Then 6, 5, and 7 years. This passed as such. Now, all these things you add together here and add with this signal that what is coming here. So finally you get Y of Y. So the subsampler, basic upsampler or X set followed by downsampler by a factor of 2. Yeah, this one X set followed by downsampler can be written simply as like this. in the polyphase way. Now let us see why this polyphase decomposition is this much important. Okay, use this page. Suppose you have a signal like this. You have the sample version. So corresponding to this signal xn, suppose you have xn equal to say 1 plus 3 sub raised to minus 1 plus 4 sub raised to minus 2 plus 6 sub raised to minus 3 plus 9 sub raised to minus 5 minus 4 plus 11 sub raised to minus 5 plus etc. Okay, and you can take these terms together. That is, you can take xn as 1 plus, as we had discussed earlier, you can take this. Then suppose you have 12 sub raised to minus 6. This also you can take. So then that become 1 plus 6 sub raised to minus 3 plus 12 sub raised to minus 6. And again, if you take these terms together, this term and this term, and suppose you have say 10 sub raised to minus 7, you can take that term also. Let us assume that you have another 9 sub raised to minus 8 also. So this can be written as plus 3 z inverse plus 9 sub raised to minus 4 plus 10 sub raised to minus 7. And if you take some other terms, say these terms together, then you have plus 4 sub raised to minus 2 plus 11 sub raised to minus 5 plus 9 sub raised to minus 8. Now this can be written as, this whole thing itself can be now written as 1 plus 6 sub raised to minus 3 plus 12 sub raised to minus 6 plus, you take z inverse outside, so z inverse into 3 plus 9 sub raised to minus 3 plus 10 sub raised to minus 6 plus, you take z raised to minus 2 outside from the next one, 4 plus 11 sub raised to minus 3 plus 9 sub raised to minus 6. This can be written as 1 plus 6 sub raised to minus 3 plus 12 sub raised to minus 6 plus z inverse into okay, this, or if I write E0 z as this term, then E1 z as 3 plus 9 sub raised to minus 3 plus 10 sub raised to minus 6, and say E2 z as 4 plus 11 sub raised to minus 3 plus 9 sub raised to minus 6, okay, raised to minus 2, minus 3. This is supposed to, okay, supposed to minus 1, raised to minus 2, minus 1, minus 2, minus 2. In this case, Xl can be written as E0 z, basically E0 z square plus z inverse into E1 z square, not z square, z cube plus E2 z raised to minus 2 into E2 z cube. So this is Xl. So basic representation is like this: Xl equal to E0 z cube plus z inverse E1 z cube plus. So this can be implemented using the polyphase decomposition. So the E0, even E2 are polyphase decompositions. Okay. So I hope you got the idea of what these things are. If you have any doubt, please ask. If there's no doubt, I will stop sharing now. Okay. I'll stop recording also.